Assalamu alaikum students. In last lecture we have discussed combinational logic and after that combinational logic we have discussed adders and in a half adder we have two inputs and two outputs. This was the truth table for half adder and we have developed the relation for sum and carry both outputs. And this was the developed diagram of half adder that actually providing us sum and carry as an output. After half adder we have discussed full adder. In full adder we have three inputs A, B, C, and here C is represented as C in. Here you can see that carry occurs for more than for sum of more than one. Either it could be 2 or 3, and sum occurs when a single one occurs, or three value occurs. So this was the relation for sum and carry, and we can develop this relation by using the output function from truth table. If you take output function from truth table and write their functional input functional values, then you can find out the relation for sum and carry. Here sum is A exclusive or B, and then after taking exclusive or with C, and for carry it is C in input carry is multiplied by A exclusive or B, and then it is added with product of A and B. So this is the simplest implementation of full adder. You can see here that for sum A is exclusive OR with B, and then after that it is exclusive OR with C, and for carry A exclusive OR B is taken as a product with C in, and both A and B are multiplied by using AND gate, and then after both outputs are ORed to get C out, carry out. So this was a simplified diagram for full adder. You can see here that you can develop full adder circuit by using two half adders and one OR gate at the output side of carry. Next is subtractor circuit. Subtractor क्या होता है? It is subtraction of two binary numbers accomplished by taking the complement of subtrahend and added back into minuend. तो जिस नंबर को आपने सब्ट्रैक्ट करना है उसका आप कॉम्प्लीमेंट लेंगे और फर्स्ट नंबर में इसको ऐड करेंगे तो हमें सब्ट्रैक्शन का रिज़ल्ट जो हमें मिल जाएगा. So it is normally done through direct method. In this method each bit of subtrahend is subtracted from its corresponding significant minuend bit to form a difference bit. If minuend bit is smaller than 1, then borrow is taken from the higher next pair of the bits. अगर आपके पास ज़ीरो वैल्यू लाई कर रही होगी तो आप क्या करेंगे, मॉन्यूमेंट में ज़ीरो वैल्यू लाई कर रही होगी तो आप बोरो लेंगे नेक्स्ट हायर बिट से, ठीक है। नाउ फर्स्ट इज हाफ सब्ट्रैक्टर. Here it subtracts two bits and produces the difference. It has an output to specify if a one has been borrowed. मतलब बोरो आउटपुट जो है वो आपको शो करेगी कि आपने कोई वैल्यू जो है वो बोरो ली है. So x and y are minuend and subtrahend variables. Subtraction, we normally check the relative magnitude of x and y. Now if x is greater than or equal to y, then there is no issue because we have result in positive form. But if x is less than y, then it is necessary to take a borrow from the next higher bit. तो जब हमारे पास अगर x बिट लोअर है तो हमें क्या करना पड़ेगा, सब्ट्रैक्ट करने के लिए उससे हायर बिट से कैरी लेना पड़ेगा, जिसको हम बोरो कहते हैं नॉर्मली. ये हाफ सब्ट्रैक्टर का ट्रूथ टेबल है. 4 कॉम्बिनेशन हैं, 0 0 0 1 1 0 एंड 1 1. x और y यहाँ पे इनपुट्स हैं. नाउ D stands for difference and B stands for borrow. तो अगर हम x माइनस वाई परफॉर्म करते हैं तो हमारे पास x यहाँ पे 0 है, y 1 है, तो हमें क्या करना पड़ेगा, हमें बोरो लेना पड़ेगा ताकि x के ऊपर बाइनरी वैल्यू बोरो होगी, बाइनरी बेस बोरो होगी. बाइनरी बेस क्या होती है, 2. तो 2 माइनस 1 विल बी 1. तो बोरो लेने के बाद हमारे पास डिफरेंस 1 आएगा, तो हमारे पास आउटपुट में डिफरेंस पे भी 1 आएगा और बोरो पे भी 1 आएगा. थर्ड कॉम्बिनेशन इज x इज़ 1 एंड y इज़ 0. सो 1 माइनस 0 विल बी 1, तो डिफरेंस 1 आएगा, बोरो 0 होगा. लास्ट कॉम्बिनेशन इज x is equal to 1 and y is equal to 1. Now 1 minus 1 will be 0, so no borrow will be taken and there will be no difference. Now for difference, you can see here outputs are high for different inputs for 0 1 and 1 0 combination, so we can implement it by using exclusive OR gate. And for borrow we have single output 1 for 0 1 combination, so we can implement it by using its input function, that is x is 0 and y is 1, so its input function will be x complement y. So in this way you can implement difference and borrow. Now we can check it by using the diagram. Here you can see that difference is taken by using x exclusive or y gate. By using exclusive OR gate, and the borrow is taken by taking a NOT for case of x input and taking y input as it is, and then applied AND gate, and after that we get borrow output. So this is half subtractor. Next is full subtractor. For full subtractor we have 3 inputs, x, y and z. Again we have 2 outputs, difference and borrow. So for the case of x minus y minus z, for this case we have if we have all inputs 0, then we have no difference and no borrow. And if x is 0, y is 0, but z is 1, then we will have to take a borrow from next bit. Then you can imagine it as uh, binary base 2 will be taken, and 2 minus 1 will be 1, so difference will be 1 and borrow will be 1. Again you can see here for next combination 0 1 0, we have y is equal to 1, so again we have to take a borrow for x, and after borrow we have value at x is 2, 2 minus 1 will be 1, so difference is 1 and borrow is again 1. In the next case we have y is 1, z is 1, and x is 0. Again we have to take a borrow. After taking borrow we have a base value of 2, so 2 minus if we add 1 and 1, 1 plus 1 2, 2 minus 2 will be 0. That's why we have 0 at difference and 1 at borrow. And for next combination 1 0 0 x y z, we have 0 at y and 0 at z, so we have only 1 at x, so difference will be 1 because we have 1 minus 0, its answer will be 1, so 1 will be at difference and 0 will be at borrow. Next is x is 1 101, for 101 combination x is 1 and z is 1, so 1 minus 1 will be 0, so we will have 0 at difference and 0 at borrow. For next combination 110, we have x is 1 y is 1, so again 1 minus 1 will be 0, and we will get 0 at both difference and borrow outputs. Now for next case we have all ones, x is 1, y is 1 and z is 1. Here we have situation where x is less than sum of y and z, so we need to take a borrow because x plus y is 2 and x is 1, so we will have to take a borrow. So after taking borrow we will have value 2, base value 2, and x value is 1, so 2 plus 1 is 3. Now 3 minus 2 will be 3 minus 2 will be 1, so we will have 1 at difference bit and 1 at borrow bit. So in this way we will create outputs for difference and borrow, and after generating the output from truth table we can generate its functional value. Here you can see that for the case of difference we have same outputs as the case of sum in full adder. Let me show you. So here you can see for sum it is 0 1 1 0, then 1 triple 1 double 0 1. So for sum we have A exclusive or B exclusive or C. Now compare it with the output of difference in truth table of 3-bit full adder, full subtractor. So here you can see it. You can see that the output of difference is 0 1 1 0, then 1 double 0 1. So we can implement it by using x exclusive or y exclusive or z. Now for the borrow output we have 0 triple 1 and triple 0 1. Here again you can see a single difference, that is x complement multiplied by y exclusive or z, and that is added with product of y and z. Let me compare the output with full adder again. So here you can see it is exactly opposite of carry out. Here you can, if you read it in the form of two pairs, that is 0001 and 0111. Now if you take its complement, then if you place upper 4 bits at lower positions and lower 4 bits at upper positions, then you will get the borrow of subtractor. Here we can check it again. Here it is. We have 0111 at upper 4 bits and 0001 at lower 4 bits. So by taking x complement we can implement this logic. So the only difference is x complement. It is multiplied by x y exclusive over z and added with product of y and z. After this you can develop the full subtractor diagram in this way. Here you can see that for difference we have implemented x exclusive or y, and then after it is again its output is exclusive or with the input z. In this way we can get the output difference. Now for sum we need to take so verify the function for the borrow and draw its diagram accordingly. Okay, this is all about today's class. Inshallah we will discuss next topic in next lecture.